Welcome to my math class. You are now on the last portion of pre-calculus, that is, trigonometry. But before we study about circular functions, let us recall some concepts that you need to know. The first concept that we are going to study is about the unit circle. In our very first lesson in pre-calculus, we have defined circle as the set of all coplanar points having the same distance from a fixed point called center. In the figure that you see on the screen, we have O as the center of the circle. Now let's say we get a point on the circle and label that point P. Then we connect point P to the center, which is O. We would be able to construct the radius of the circle. The radius of the circle is the distance of a point on the circle from the center. Now let's say we get another point on the circle and label that R. Then we form another radius of the circle. Take note that these radii have the same length. Now taking together these two radii that you see on the screen, we would be able to form an angle. And take note that this angle intercepts a portion on the circle. Now this portion of the circle is referred to as the arc of the circle. Now this angle, whose vertex lie at the center of the circle, is called the central angle. Now, if we take into consideration the interior points bounded by the circle, we would be able to get a sector. A sector is a portion of the set of interior points of a circle. Now let's study about the characteristics of a unit circle. The unit circle has a radius that is equal to 1 unit. That is why it is named as the unit circle. The measure of the central angle is equal to the measure of the intercepted arc. In this figure, the measure of angle theta is equal to the measure of the arc PR. Another property or characteristic of a unit circle is that when you have angle theta that is equal to the ratio of the arc, the measure of the arc, divided by the radius. Please be reminded that theta should be in radian measure. And the last property that we are going to study is about the area of a sector. The area of a sector can be found using this formula, which is 1/2 times theta times r squared. Always remember that the angle theta here should be expressed in radian measure. The second concept that we have to be clarified on is the angular measure and the linear measure. The angular measure is the measurement of the angle between the two radii of the circle, while the linear measure is the physical distance between the points on the circle. So in this illustration, the linear measure refers to the measure of the arc, while the angular measure refers to the measure of the central angle. The measure of the central angle and the arc of a circle can be expressed in radian or in degree measure. Now, what's the difference between the two? According to mathematicians, they just differ in the perspective. Radians is better used if you are the runner, while degree is better used if you are the observer. What does this mean? For example, your friend is running around a circular racetrack, and you are standing at the center of the racetrack and you are observing your friend is running in the racetrack or on the racetrack. If your friend will be asked about the distance that he or she has traveled, it is better to express the distance or the measure of the arc in radians. While if you're going um, to measure the movement of your head as your friend starts to move, then it is better to use or to express your answer in degree measure. Let's say we get a point P on the circle that is moving. One complete rotation of the points will make a 360-degree angle. Now for the arc, that is equivalent to 2 pi. How come that is equal to 2 pi? Remember that in a unit circle, we have r equal to 1. Recall also that the circumference of a circle is equal to 2 pi r. If the radius is equal to 1, we substitute 1 to r. Simplifying, that will give you 2 pi. In other words, 360 degrees is equivalent to 2 pi. Now what if the point has moved only up to this point or up to that location? This forms now a straight angle which is 1/2 of 360 degrees. And take note that the intercepted arc is a semicircle, which is 1/2 of 2 pi. Dividing both sides by 2, then we would be able to get pi equal to 180 degrees. So therefore, if you will be asked to compare the relationship of degree to radian, we would be able to arrive at 1 degree is equal to pi over 180, which is approximately equal to 0.17453292 and so on, while 1 radian is equal to 180 over pi degrees, or approximately equal to 57.2957791 and so on. So in other words, 1 radian is equal to approximately equal to 57.3. Now let's try to convert measures from radian to degrees and vice versa. Now take a look at these two circles, and we have some missing angles. Okay, on the first circle, the measure is given in degree measure, while on the second circle, the angles are given in pi radian. Now the let's complete the measures of the given circle. Now take notes. It's like this missing number or missing angle is equivalent to pi over 6. So let's try to convert pi over 6 to degrees. Now take note that pi is equivalent to 180 degrees. To be able to convert pi over 6 to degree, we have to multiply this number or this given by 180 degrees over pi. So this time we can cancel this. Then we will have 1, 1. Then we divide also by 6. So 6 divided by 6 is 1. 180 divided by 6, that is 30. So therefore, pi over 6 is 30 degrees. Okay, so we have 30 degrees. Now what about this missing measure between 300 and 330? So getting the equivalent, it's equal to 7 pi over 4. Let's convert that. Let's follow the same procedure. We are going to multiply by 180 degrees over pi. So we can cancel the pi radian. So this is 1, or the symbol pi. Now we divide the numerator and the denominator by 4. So 4 divided by 4, that is 1. Now 180 degrees divided by 4, that is equal to 45. So therefore, we multiply 7 by 45. We will have 7 times 5, that is 35. 7 times 4, 28, plus 3, that would be 31. So therefore, 7 pi over 4 is 315 degrees. Okay. Now, the last blank corresponds to 4 pi over 3. So let's convert 4 pi over 3 to degrees by following the same strategy. Okay. So the symbol pi can be cancelled. Okay. We cancel this, so this is 1, this is 1. Now we divide by 3, this is 1. 180 divided by 3, we have 60. So multiplying that, we will have 240. 4 times 60 degrees, that is equal to 240 degrees. Now what about from degree to pi? Okay, so let's see. Here we have 45 degrees. So how can we convert 45 degrees to pi radian or to radian? Now we write 180 degrees in the denominator while pi in the numerator. We can cancel or divide by 45. 45 divided by 45, we will have 1. 180 divided by 45, that is equal to 4. So therefore, the correct answer would be pi over 4. Okay, so that means 45 degrees is equivalent to pi over 4. What about this missing measure between 3 pi over 4 and pi? So that is equivalent to 150 degrees. Okay, following the same procedure, we multiply by pi over 180. So we get the GCF 150 and 180, that is 30. Okay, so we divide by 30, 150 divided by 30, that is 5, while 180 divided by 30, that would be 6. So we perform now the multiplication. So 5 times 5, that is 5 pi over 6. Okay, that means 150 degrees is 5 pi over 6. What about 270 degrees? So we do the same. 270 times pi over 180. Okay, we can cancel using the GCF. 270 divided by 90, that would be 3, while 180 divided by 90, that would be 2. So therefore, the answer would be 3 halves pi, or 3 pi over 2. Okay, so 270 degrees is equal to 3 pi over 2. Okay. So to present to you the complete figure, here we are. So you can see that 150 is equivalent to 5 pi over 6. I would like you to master the measure of these angles, for this will be of great use once you have mastered the different angles. Okay, these are somewhat related to special angles in a circle. Now let's proceed to angles in standard position. Among the 4 angles presented on the screen, can you guess which of the angles are in standard position? Let's analyze. It is said that the angles in standard position should have this property or characteristics. The vertex should lie at the origin. Among the 4 angles, which angles lie, or which angles whose vertex lie at the origin? Let's see. Angle in option A, check, in the origin. Angle B, or the angle in B, is at the origin also. C is at the origin also, and also D is at the origin. Okay. Now, the second characteristic is that the initial side coincide with the positive x-axis. Among the 4 angles, only angle D do not have an initial side that lie on the positive x-axis. So therefore, angles in A, B, and C are angles in standard position. The measure of an angle in standard position can be positive or negative. If the measure of an angle is positive, it means that the angle is rotating in a counterclockwise direction, whereas if we have a negative measure, it means that the angle is rotating in a clockwise direction. So remember that if the direction is in a clockwise manner, we have a negative angle. Whereas if the direction is counterclockwise, then the measure of the angle is positive. So for example, coterminal angles are angles in standard position having the same terminal side. So let's emphasize two distinguishing characteristics for coterminal angles. So for example, we have here an angle. Okay, let's say this angle is 45 degrees. Okay, since it's in counterclockwise direction, okay, we have a positive measure. Now let's determine the smallest positive angle and the smallest negative angle. So for the positive angle, we shall rotate from the initial side. So in one full rotation, that is 360 plus another 45. So that means we will have 360 degrees plus 45 degrees. That would be 405 degrees. So therefore, we have an angle measuring 405 degrees is coterminal to 45 degrees. That's the smallest positive angle. Now, what about the smallest negative angle? So let's rotate in a clockwise direction. So we have here. Okay, one full rotation is 360, but however, we still need 45 degrees. So all we can do is just to subtract 45 degrees from 360. That will give you 315 degrees. However, since it is in a clockwise direction, we shall be affixing a negative sign. So 315 degrees is the measure of an angle that is coterminal to 45 degrees. Another term that we need to understand is the reference angle. It is referred to as an acute angle formed by the given angle with the x-axis. So for example, you have an acute angle. Okay, first it should be an angle in standard position. If you have an acute angle in the first quadrant, you don't have to get another acute angle. However, if it lies on the second and third, you need to get another acute angle. Okay, so let's say we have an acute angle on the, or not an acute, let's say we have an angle here. Okay, so let's say this angle is 200. Okay, so let's say we have 210. Okay, so 210. Now the reference angle would be the angle formed by the x-axis. Okay, so since it's on the third quadrant, then this will be the x-axis. Okay, the angle formed by the terminal side and the x-axis would be the reference angle of 210. So let's find out. If this is 180 and this is 210, we can just subtract 210 degrees minus 180 degrees. You have 30 degrees. Okay, so the reference angle of 210 degrees is 30 degrees. Another very useful concept that we have to recall is the right triangle trigonometry. Okay, so remember our pun, which is SOHCAHTOA. Okay, so that means sine of an angle is equal to the ratio of the opposite over hypotenuse, while for cosine we have adjacent over hypotenuse, and tangent equal to opposite over adjacent. So in here, let's solve the given triangle. Okay, we have 30, then this is 90 since there is symbol, so angle C is 90 degrees. Now to find angle A, we know that in a right triangle, the acute angles are complementary. So 90 minus 30, then you will have 60 degrees. So we have 60 degrees for angle A, then 90 for angle C. Okay. What about AC and BC? We use now the trigonometric ratios that we have recalled. So let's say we have AC, that is here. Okay, this is the side. Now, what ratio involves opposite and the hypotenuse? Okay, that is sine. So sine 30 degrees, okay, sine 30 degrees is equal to opposite side, that is AC. Then we have 8 for the hypotenuse. So sine 30 degrees, that is 1/2. Okay, we can cross multiply already. 1/2 times 8 equals AC. So simplify, AC is equal to 4. Okay, so this would be 4. Now, for BC, we have to get, or we have to use cosine 30 degrees equal to adjacent is BC, then hypotenuse 8. So using our calculator, we compute for 8 times cosine 30 degrees. That would be our the length of BC. So 8 times cosine 30, that would be approximately equal to 6.93. So therefore, BC is 6.93 units. Okay, we were able now to find the missing values of the parts of the triangle. Quadrantal angles are angles whose quadrantal angles are angles in standard position whose terminal side coincide with the x-axis or y-axis. So for example, we have here an angle measuring 90 degrees. Okay, the terminal side coincide with the positive y-axis. So we have an angle, we're having a measure of 90 degrees is a quadrantal angle. Now, another angle could be an angle that measures 180 degrees. So we have a straight angle. Continuing the movement, okay, counterclockwise, we will have 270 degrees. Then back to 0, or we shall have one complete rotation, we will have 360 degrees. So in other words, the measure of quadrantal angles are in multiples of 90. Let's plot the unit circle and the coordinate plane. So since we have r is equal to 1, this is the origin, then this is 1 unit. So therefore, this point has coordinates 1, 0. This point has coordinates 0, 1. Then here we have negative 1, 0. And the last one we have 0, negative 1. Now what if we have the quadrantal angles like, let's say we have this in a counterclockwise direction, so theta is equal to pi over 2. So let's say we have a 90-degree angle. Then take note that this is equivalent to, let's say, this can be expressed as pi over 2, p of pi over 2, which is equal to the coordinates of this point. Okay. Now the second illustration, we have P of pi, and that is equivalent to negative 1, 0. Let's say we have a trigonometric point that is equivalent to 3 pi over 2. Okay, so this is 3 pi over 2. And take note that this point has coordinates 0, negative 1. Now, if we rotate in a clockwise direction, then we will have P of negative pi over 2. Still, we have 0. The corresponding trigonometric point will have coordinates 0, negative 1. Okay. Now what if we have one complete rotation? Okay, then we will be back to 1, 0. So P of 0 degree, or P of 0 is 1, 0. Or let's say we have 2 pi, then we still have 1, 0. Now what if we have an angle that is not a quadrantal angle? Okay. This can be the trigonometric point that is equivalent to that is found using our right triangle trigonometry. So let's say we have this point, and since this is a unit circle, then its radius is equal to 1. And we have this angle theta. Then this point will have coordinates x, y. Okay. Then we draw a broken line that is perpendicular to the initial side, or to the x-axis. Okay. Then we also draw a line that is perpendicular to the y-axis in order to form a rectangle. So that means this is also x, okay, and this also y. Now since we are just concentrating on this right triangle, then it's enough to have this sphere. Okay. Okay, now let's say that this is equal to pi over 4, or your theta, our theta, P of theta is pi over 4. Okay, so that means we will have P of pi over 4. Okay, let's find the trigonometric point equivalent to this, pi over 4. Okay, since we have here pi over 4 that is exactly at the middle between 0 and pi over 2, so that means we have formed an isosceles right triangle. So this is x and this is y. Using Pythagorean theorem, we will have x squared plus y squared. The sum of the square of the legs is equal to the square of the hypotenuse. Now we know that r is equal to 1, so replace r by 1. So we will have x squared plus y squared is equal to 1. Now since this is isosceles, then x is equal to y. Let's just use one variable, so this means we can just write x squared plus x squared if we would like to replace y by x. So simplifying this, we will have 2x squared, then equal to 1. We divide by 2. So we have x squared is equal to 1/2. Then we extract the square roots on both sides. So x is equal to 1 over square root of 2. Now, take note that 1 over square root of 2 is not in the simplest form because we say that an answer in the simplest form should not have a radical in the denominator. So we rationalize 1 over square root of 2 by multiplying that number by square root of 2 over square root of 2. So 1 times square root of 2, that is square root of 2. Now in the denominator, 2 times 2, we will have 4. Square root of 4, we will have 2. So therefore, x is equal to the square root of 2 over 2. Now since this is equal to y, therefore we can express, okay, that the trigonometric point will have a coordinate of square root of 2 over 2, square root of 2 over 2. Let's have another example. So let's say we have 2 pi over 3. Okay, we are asked to get the trigonometric point that is equivalent to 2 pi over 3. Okay, in this case, we use a reference angle. Okay, so we drop a vertical line that is perpendicular to the x-axis. Okay, so this is x, and we find the measure of this angle. Okay, so here we know that we have pi. So in order to find our reference angle, we subtract, okay, 1 pi minus 2 pi over 3. That means we have pi over 3. So this is just equal to p of pi over 3. Okay, pi over 3, that is equivalent to 60 degrees. Okay, so remember that in a 60-90 degree, 60-30-90 degree triangle, the measure of the opposite side is 1/2 the hypotenuse. Okay, so if this is 60, then we will have 30 here. Okay, so that means x is equal to, okay, what is 1/2 of 1? That is 1/2. Okay, so what about y? We can use Pythagorean theorem. Okay, the same as what we did a while ago. Okay, our x is 1/2. Okay, then r is 1. Simplifying, we will have 1/4 plus y squared is equal to 1. Transpose 1/4. Y squared is equal to 1 minus 1/4. We will have 3/4. Extract the square roots on both sides, so you will have y is equal to the square root of 3 over 2. So therefore, this is equivalent to 1/2 square root of 3 over 2. Okay, now let's say you're asked to find the exact value of cosine 225. So let's try to determine what quadrant that angle having a measure of cosine having a measure of 225 degrees lie. So let's see if we have here the initial side. So we have 0 degrees, this is 90 degrees, 180, 270 degrees, and so on. This is 360. Okay, so 225, that is on the third quadrant. Okay, so let's try to find a reference angle. Okay, so that means our reference angle would be this one. Okay, so What's the measure of this angle? We will subtract 225 minus 180. Okay, that will give you 45 degrees. Okay, so that means our reference angle is 45 degrees. You were asked to get cosine 225. Okay, so if you have a 45 angle here, then let's have a line that is perpendicular to the x-axis. Then we can make we can construct here now an isosceles right triangle. That means that the legs are equal. So let's say if this is 1 unit, so let's say -1. Okay, you can have here, so that's equal to x. Then if that is -1, then this is also -1 because they are isosceles. So to get the hypotenuse, all you have to do is to have the Pythagorean theorem. So x squared plus y squared is equal to r squared. That means 1 squared plus 1 squared is equal to r squared. We will have 2, so r squared. Extract the square root, so r is equal to the square root of 2. So here we have square root of 2. Since we have cosine, all we have to do is cosine 225 degrees or cosine 45 degrees. We will have, okay, adjacent is -1, hypotenuse is square root of 2. So what will be our final answer? Okay, we rationalize. So we have negative square root 2 over 2. That is the exact value of cosine 225. Let's work on with the next example. Find the exact value of the 6 circular functions of a negative angle theta whose terminal side passes through the point 1, -2. So we start by sketching the angle on the coordinate plane. We try to find at what quadrant will the terminal side lie. So since we have 1, -2, take note that in the fourth quadrant we have positive x, negative y. So let's say we have here, let's say 1, 2, okay, then here we have -1, -2, okay, so 1, -2, this is the point with coordinates 1, -2, okay, so we draw the angle. Okay, this is the angle that passes, or the terminal side that passes through the point 1, -2. Now, since we are given that it is a negative angle, therefore, the terminal side is moving in a clockwise direction. Okay, so here take note that we have x equals 1 and that y is equal to -2. Okay, if we will drop here a line that is perpendicular to the x-axis, we would be able to make a right triangle. Okay, or you can simply apply the Pythagorean theorem, which is x squared plus y squared is equal to r squared. Okay, so we substitute, we will have 1 squared plus, since we have length, we shall use positive 2 squared, then we don't know the radius. So that means we will have 1, then we have 4 r squared, so we have 5, extract the square roots, so we will have r is equal to 5. Okay, so we have now square root of 5. Now to find the 6 circular functions, we shall have sine theta. Okay, opposite, we have negative 2 over hypotenuse, we have square root of 5. So we can just rationalize. So we multiply by square root of 5 over square root of 5. Therefore, we will have negative 2 square root of 5 over 5. What about the cosine function? Cosine is adjacent, so we will have x1 over square root of 5. So we will have square root of 5 over square root of 5. Simplify that, we will have square root of 5 over 5. Now what about tangent theta? Tangent is x over y, or y over x. So negative 2 over 1. Therefore, tangent theta is negative 2. Okay. Now, we get the reciprocal functions. So we have cosecant theta, get the reciprocal of negative 2 over 5. That would be square root of negative 5 over negative 2. Okay. For cosine theta, it's just inverse 1 over square root of 5. That means we will have square root of 5. If we will have tangent, that's equivalent. The reciprocal function would be cotangent theta. Get the reciprocal of negative 2 over 1. That would be negative 1/2. So these are now the exact value of the 6 circular functions of a negative angle whose terminal sides passes through the point 1, negative 2. Let's consider the third problem. Consider the terminal point P having coordinates negative square root of 5 over 5, then 2 square root of 5 over 5 for y, determined by t. Verify that P is on the unit circle. Now, to determine whether this point is on the unit circle, just check if we will have an identity after replacing the node. Okay, since we have a unit circle, r is equal to 1. For y, we shall have 2 square root of 5 over 5. Okay, then for x, we will have negative square root of 5 over 5 squared. So simplifying that, we will have 5 over 25. Here we will have 4 times 5, 20. Then 5 squared is 25. So we have 1. Add 5. Since we have a similar fraction, we can just add the numerator. So we will have 25 over 25. That is simply equal to 1. Okay, that's it. Now let's explore real-life applications of what we have learned in today's lesson. Okay, let's have the first problem. Carl created a life-size replica of an antique car and was displayed during an exhibit. Each of the wheels has a diameter of 10 inches. Accidentally, it was pushed by an exhibit viewer and was displaced. If the wheel made one complete revolution, will it damage a display 40 inches next to it? So take note, one complete revolution, that is 360 degrees. Okay, now we are going to determine the displacement of the antique car. It's just like getting the circumference of the circle. So if the circle has a diameter of 10 inches, then we get the circumference. Okay, using diameter, we have pi d. So pi times 10. So let's assume that pi is 3.14, or you can just type in your calculator. Make sure that, okay, you have 10 pi, so 10 times pi, that is 31.415, or approximately equal to 31.42 inches. That's the displacement. Now, answer the question. If the wheel made one complete revolution, will it damage the display 40 inches next to it? Okay, 31.42 is less than 40 inches. Therefore, it did not damage the next display. That is 40 inches next to it. Okay, now let's work on. A 12-inch pizza was cut across the center. If it was divided equally into 8 parts, how big is a slice of the pizza? We then illustrate the given. A 12-inch pizza, that means we have a diameter of 12, so therefore R is equal to 6. Now this pizza, circular pizza, was divided into 8 parts. Now, one full rotation is 360 degrees divided by 8. That will give you, okay, we can use calculator to have a shorter process. So that would be 45 degrees. Okay, so that means we have each angle is 45 degrees. Now remember that if we're going to get the area of this slice, our theta or angle should be expressed in pi radian. So convert 45 degrees to pi radian. We shall have a 45. That's the GCF, so this is 1. Then 180 divided by 45, you will have 4. So that means theta would be equal to pi over 4. Again, for the area of the sector, we will have 1/2 theta r squared. And remember that theta is in the radian measure. So let's plug in the given. So we have pi over 4. Then we have a radius of 6 squared. So we will have 36 pi over 8. Simplifying that, Okay, we can divide by 4. 36 divided by 4, 9. 8 divided by 4, we have 2. So 9 halves pi square inches. That would be the slice of the area of the given sector, which is equivalent to 1 slice of pizza. Now let's have the last example, which is about angular and linear velocity. On a horse track having a radius of 600 meters, an equestrian is riding his horse trotting at a speed of 50 meters per minute. Find the angular velocity of the binocular of an observer standing at the center of the horse track. So let's just define the linear velocity is given by v equals s over t, where s is the displacement and t is for time. For angular velocity, we have omega equals theta over t, where theta is the measure of the angle in radian and t for time. These two are related to each other. Okay, linear velocity and angular velocity is expressed, or their relationship would be v is equal to r times omega. The complete proof is presented in the book, so you can just read further how come we have arrived at v equals r times omega. Okay, so let's go back to the problem. What is 600 meters? That would be r. While 50 meters per minute, that is our linear velocity. Okay, so LA. Okay, so substitute in the formula. Okay, we have here the linear velocity is okay 50 minute per this is 50 minute per, or meters rather. Okay, so this is 50 meters per minute. The radius is 600 times the angular velocity. So that means we will just divide 50 by 60 or 600. Okay, this is in meters times minute. So therefore, what is 50 over 60 or 600 rather? That is 1 over 12, so 1 divided by 12. So that means the angular velocity is 0.08333 revolution per minute. Okay, so I hope you were able to learn a lot of things in today's lesson. See you again.